This is Calculus 2 class. We're gonna study trigonometric integrals. We studied integration by parts, substitution method. Now, we're gonna study trigonometry integrals. First step, you have to recognize when integral involve powers, a product of trigonometric function. Then we're gonna apply trigonometric identities to simplify integrals. Third, evaluate using substitution and reduction strategy to evaluate trigonometric integral. Let's get started. First one is sine x and cosine x. They have odd power. So what you have to strategy gonna be, state one fact, use of with others, sine square x equal 1 minus cosine square x. So what does it mean by that? I give the example right there. Integral sine cube x. Cube is odd power, right guys? Odd power. Save the sine x, one sine x, and you say sine square x times just sine x. Let's make a sine cube x. Then you're gonna use trigonometry identity. Sine square x equal 1 minus cosine x. That's you're gonna use it. Then you have 1 minus cosine square x times just sine x. Now, let's go back to integration right there. Integral 1 minus cosine square x sine x dx. Now you're thinking about using some method to evaluate this integral. Which method is working, guys? You clearly see you can apply user y. U gonna be cosine x, du gonna be negative sine x dx. Now, go back to the original integration, you see 1 minus u square, cosine x is u, that's why u square, sine x dx gonna be negative du, so u times negative du, negative distribute, that's gonna be u square minus 1 du. Then you find antiderivative u square minus 1, that's u cube over 3 minus u plus 3. We practice about substitution method. You're gonna be plugging back. You're gonna be cosine x, so final answer gonna be cosine cube x over 3 minus cosine x plus c, guys, okay? That's the first one. So let's go to one more time. So power is odd. What do you mean by that? Next one, guys. Power is odd. We're talking about save the one factor, use the use of with other identity. You're going to use this time, we're going to use cosine square x equal 1 minus sine square x. This one is, you see, cosine have power is 3. So cosine square x gonna be leave the one factor cosine x there. Then cosine square x replace with Pythagorean identity 1 minus sine square x. So that case, you have 1 minus sine square x times cosine x. Then you have integration, change it. Integral 1 minus sine square x cosine x dx. Now, what is u this time? Can you guess? U gonna be sine x, du gonna be cosine x. You're gonna substitute integral 1 minus u squared du. Then you find antiderivative 1 minus u squared. That's gonna be u minus u cube over 3 plus c. You're gonna be plugging back. You're gonna be sine x. That you have sine x minus sine cube x over 3 plus c. Everything make sense? Let's do one more example about this case. So we keep working on the power is odd. Let's see. Integral sine cube x cosine square x. See, which one is odd? Here is odd, right? Then odd part gonna be, we're gonna rearrange it. Sine cube x is sine square x sine x. So now sine square x gonna be replaced 1 minus cosine square x. Then you have 1 minus cosine square x sine x. Go back to integration. So now we have integral 1 minus cosine square x sine x cosine square x dx. What are going to be substitute, guys? Before that, we rearrange integrand. Now you see, what are going to be u this time? Can you guess? U going to be cosine x. Du going to be negative sine x. So sine x going to be negative du. So replace everything here, guys, by using substitution method. Right here, guys. Integral 1 minus u squared because u is cosine. U squared because u equal cosine. Sine x dx gonna be negative du. So let's distribute. U times 1 is u squared times u squared, u fourth. Then you times negative. Then you have u fourth minus u squared du. Then we're gonna find the antiderivative. That's gonna be u fifth power over 5 minus u cube over 3 plus c. Now you plug in back, u equal cosine x. So you have a final answer. Cosine fifth power x over 5 minus cosine cube x over 3 plus c. That's power is odd. You can use Pythagorean identity. Now, power is even. What are you gonna do? We're gonna use power reduce formula right here. So power is even, guys. Power is even. So you're gonna use power reduce formula. Sine square x equal 1 minus cosine 2x over 2. That's we're gonna use it. Then you plug in back into the integration. You have integral 1 minus cosine 2x over 2 dx. 1.5 is outside. Integral 1 minus cosine 2x. I separate the integral 1 dx minus integral cosine 2x dx. So first, I'm gonna find integral cosine 2x dx. You're gonna using new sub, guys. You're gonna be 2x, you're gonna be 2 dx. That's gonna be integral cosine u over 2 du. That's gonna be sine u over 2 plus c. You're gonna be plugging back sine 2x over 2 plus c. Guys, make sense? Now, plugging back into the original integration, you have here 1.5. Antiderivative 1 is x. Integral cosine 2x dx gonna be sine 2x over 2 plus c. Now you can distribute to 1.5 x over 2 minus sine 2x over 4 plus c. So guys, remember, power is even. You're gonna use power reduce formula. Power is odd. You're gonna use Pythagorean theorem. So let's do one more, guys. Look at this. This time I have cosine square x. Power is even, right? Then in that case, we're gonna cosine square x equal 1 plus cosine 2x over 2. So let's do this one. So integral 1 of cosine 2x over 2 dx. Now take out 1.5, integral 1 plus cosine 2x. We did previous slides, that's separate, find cosine 2x dx, exactly same thing. That's gonna be sine 2x over 2 plus c, plugging back. 1.5, antiderivative 1x plus sine 2x over 2 plus c, distribute to 1.5. You have x over 2 plus sine 2x over 4 plus c. That's we study sine cosine with even or odd power. Now, let's do tangent and secant. So first one is, you have very carefully see, even power of sequence. Okay, even power of sequence. You save secant square x, then you're gonna substitute, you're gonna be tangent x. What do you mean by that? Let's see this one. Integral tangent cube x secant 4x dx. You see power is 4 there. 4 gonna be separate secant square x, secant square x. So save one secant square x gonna be replaced by secant square x equal tangent square x plus 1. That's another Pythagorean identity. Then you have tangent square x plus 1 times secant square x. Guys understand that? Even power of a secant, you save one secant square x, the other secant square x gonna be replaced with Pythagorean identity secant square x equal tangent square x plus 1. So going back to original integration now, integral tangent cube x tangent square x plus 1 secant square x. Can you guess what kind of use of you're gonna use? I already put on the top. You're gonna be tangent x, right? Du gonna be secant square x. Outside they have secant square x dx. That's why I use u sub u equal tangent x. Let's replace everything. So integral u cube times u square plus 1 du, distribute u cube, that's gonna be u fifth power plus u cube du. That's a simple polynomial function. You can find the antiderivative. That's gonna be u 6 power over 6 plus u fourth power over 4 plus c. Now plugging back, you're gonna be tangent x. You have final answer for this indefinite integral tangent 6 power x over 6 plus tangent 4th power x over 4 plus c. Guys, make sense? Now, what are you gonna do next? The next one is we're gonna do odd power of tangent x. So you have looking for tangent x, secant x. You're gonna use the use of secant x, right, guys? Okay, look at this one. You see, tangent gonna be odd power because that's one. Secant is odd. You don't care about secant odd power. Tangent odd power, then you're gonna looking for tangent secant. So you need one more secant. That's why I separate secant qx equals secant square x secant x. Guys, make sense? So you plug it back. Tangent x times secant square x secant x. You rearrange it because I'm looking for tangent x secant x. So that's why you have secant square x tangent x secant x dx. Now I gonna use sub. You're gonna be what? Secant square x. Du gonna be tangent x secant x dx, right? Then you're gonna use u sub. Now we have integral u square du. Find the antiderivative u square gonna be u cube over 3 plus c. Now plugging back, u equals secant x sequence 2x over 3 plus c. Let's do one more time, guys, okay? So look at that. This is my example, guys. Do one more example. This one is a tangent cube x. There is no secant x. So first step is we have separate cube. That's gonna be tangent square x, tangent x. So then what are you gonna do? We're gonna use identity tangent square x secant x minus 1. That's going to be secant x minus 1 tangent x. Distribute tangent x, secant x times tangent x minus tangent x. Now, go back to integration. Secant square x tangent x minus tangent x dx. I separate integration, secant square x tangent x dx minus tangent x dx. You have to do two separate integration. I'm gonna do first one. That's a secant square x, tangent x dx. So which method are you going to use, guys? You should use u sub. So you're going to be tangent x because secant square x, power is even. Then you're going to be secant square x dx. Substitute. That's going to be integral u du. Find the antiderivative. U square over 2 plus c. Plug in back. You have tangent square x over 2 plus c. That's the first integral. Second integral gonna be tangent x. So I wanna find tangent x, but you have to use trigonometric identity. You change it, sine x over cosine x. Can you guess what kind of method you're gonna use? You're gonna use the use sub. You're gonna be cosine x, you're gonna be negative sine x dx. That's you're gonna use the use sub. That's gonna be integral negative 1 over u du. You put the negative outside. Negative integral 1 over u du. Now you have ln function, negative ln absolute value u plus c. You're gonna be cosine x, negative ln absolute value cosine x plus c. Let's plug in back into the original integration. First one is tangent square x over 2 minus ln cosine x plus c. So final answer gonna be tangent x plus ln cosine x plus c. What do you learn this session? We learn trigonometric integral, but you have to be very careful with the power of trigonometric function. Odd or even, they have different substitution choice. Guys, make sure which identity you're gonna use. You're gonna use Pythagorean identity, double angle, half angle. That meaning is a power reduced formula to simplify. Second is the secant tangent integral. Often you have different strategy you need. Make sure which strategy you're gonna use. Finally, complex trigonometric integral can be broken down into manageable steps. So you have understand power of trigonometric function, then you decide which identity you're gonna use.